Let's take a look at filament sensors. And there's really, well, there's a couple kinds, but we're just going to look at three of them. The first one is imagine that you've got some sort of black box, and into that comes our filament. We got a nice pink filament that's coming in. And inside of that box, we have a limit switch. Let's actually make it a nice purple. I always like doing purple stuff. Cool. So we got a nice limit switch in here. So a limit switch is just essentially an analog, or well, it's a digital device. Fundamentally, it's analog, but digital device. We're gonna have a little roller on there, and so when filament is present, we're gonna have this switch compressed, right? So it's being pressed down. When filament is not present, since it's got a little spring built into it, it will the switch will open up and it will move in that direction, and so it'll open or close the contact depending on how it's working. So that's one way. It's just a switch, right? So switch. Another type of filament sensor is a UV or IR. Sorry, yeah, I've got UV on the brain, but yeah, so IR sensor. So how that works is we'll do something like this. So we got our filament. Well, actually, let's draw this first. So we got some sort of IR emitter, and then on the other side, we've got some sort of IR receiver. When I say IR, I just mean IR light. And so this is pretty straightforward because when we have filament present, the receiver isn't getting light. So this is another system, so we can just call this, we'll just call it IR. So this is nice because this is no contact, and sometimes this mechanism can get jammed, but it is nice and inexpensive. This you can just have it the filament hovering in the zone between these guys. And then the last one I want to look at is a little bit different. It's kind of similar to the IR component. So let's say we got a black box again. Whoa. Some big black box. Ta-da. And on one side, we've got some sort of IR light source, or this doesn't even have to be IR, just some sort of light source. This one has to be in a black box, by the way. We have to have it in a black box in order for this to work. You'll see why shortly. So we've also got our filaments coming through here. Great, I love it. Filaments coming through. Now, what we're going to have on this other side is a receiver, just kind of like IR, except for I'm going to make it like some sort of like photo cell, almost like a solar panel, or solar cell. Now, think of, oops, photo cell's only spelled with, here, I'll fix this, it's an excited photo cell. Anyways, so when filament is present, it will cast a shadow, and so this photo cell won't get as much light as if the filament was not there. So this can work in kind of a binary way, kind of like how these filament sensors work, the switch and the IR, in that you can basically say yes, no, there is filament, which can be really handy because then we can stop our print. However, an advantage of this guy having it nice closed in a black box is it can also function as a width sensor. Right, so as a width sensor, so let's think about this real quick. If we have something like a little plot here, the filament width, and here we've got the voltage out of the solar cell. And maybe we're looking at current. It doesn't really matter. So the relationship, it's probably not going to be exactly like this. It's probably going to be something like a downward trend, right? So as the width increases, the voltage that this little cell is generating is less. And so as long as you can characterize this function, you can figure out what the width of your filament is. And what is the use of that? Like, why do we care about our width? Well, especially if you're kind of in this big rep rap mindset, you're usually in a DIY mindset. And a lot of DIY people like to think about things like home extrusion, i.e., making your own filament, right? If you're making your own filament, one of the biggest components of that is making sure that your diameter of your filament stays constant. And so something I would like to see more and more in printers is this type of width sensor that can actually detect if your filament is a little small or a little big and automatically adjust for that change. Because obviously if it's too small, then you'll over extrude. If it's too small, you'll under extrude, and if it's too big, you'll over extrude. So anyways, and this obviously is a little bit more expensive of a system and more complex to make, but it is neat nonetheless.